Alright, balancing equations can be fun, but usually it's the start of a later problem, such as writing a precipitation reaction or a gas evolution reaction. Or oftentimes you're asked to write a balanced equation and a net ionic equation. But balancing is something that needs to be done all the time. So let's balance a few equations. So let me just make something up here. Let's say that we have aluminum hydroxide, and this is an aqueous solution, plus, let's say, an iron 2 chloride, and this is also aqueous. Now, with double displacement, we're going to get aluminum chloride. Let me reduce the size of this here. Alright, and we're going to get aluminum chloride, aqueous, and iron 2 hydroxide. And for our purposes, we'll say this is aqueous. We're interested in balancing this. We can look up later whether or not that's a solid that forms. Okay, so the key to balancing is simply making sure you have the same number of atoms on both sides of the equation. So let's just start with a quick tally of what we've got on the left half of this. Alright, we've got 1 aluminum right up here. We've got 3 oxygens. So we've got this OH group where we got 3 of them. So 3 oxygens and 3 hydrogens. And then in the iron 2 chloride, we've got 1 iron atom, and we've got 2 chlorine atoms. So now on the other side, here it's a little different. We've got 1 aluminum, 3 chlorines instead of 2. We've got 1 iron, and we've got 2 oxygens and 2 hydrogens instead of 3, like we had on the other side. So we need to increase the number of oxygens on this side. So we need more oxygens, we need more hydrogens, and over here we need more chlorine. Notice that I'm saying we need to add things. We can never subtract things. We can't say, oh, we need to we need to remove a chlorine from this side so that there's 2 on each side. Or no, the other way around. Chlorine's on the other side. We need to remove a chlorine over here. No, we wouldn't say that. So we can only add atoms. So we're going to have to increase the chlorine on the left, and we need to increase the OH on the other. So we just start, that's kind of this is where the fun comes in. You need to just start putting some numbers in front of these molecules and seeing what we can do. So we know we need more chlorine on this side. Can we just add 1 chlorine? I mean, they come in this package. They come in the iron 2 chloride package. So every time we add chlorine, we have to add an entire iron 2 chloride. So we have to add them 2 at a time. So we can double up on that. We could put a 2 here. We can do that in a different color. We can put a 2 in front of the iron 2 chlorides. That gives us now, for our count, a 2 for iron, and it gives us 4 for chlorine. But I don't think that's going to work, because if we look over here at chlorine on the other side, we see that there's 3, and they come in 3s. Every time we add another iron or aluminum chloride, we get 3 of these chlorine atoms. So that's still 1 too few, right? Now we've got 4 over here and 3 over here, so that's not going to work. So we need a number that's actually going to give us the same. We need to do something to both sides that'll give us the same number of chlorines, and that's the best place to start. So let me show you what I would do. I would put a 3 here in front of the iron 2 chloride and a 2 in front of the aluminum chloride. because this will give us 6 chlorines on both sides. That's the smallest number that we can get. We can't have any less than 3, or any less than 2. Well, actually, we need 3. We can't have less than 2. We can't have 4 because that didn't work. We can't have 5. So 6 is the only one that works. So if we do that, it's going to change. It's going to change some numbers. So let's just erase all our numbers here. Okay. So this gives us now 3 irons, right? And this gives us, let's just get a new count. We have 3 iron, we have 6 chlorine, and here on the other side we have 6 chlorine, and we have 2 aluminum. Alright, but we're going to need 3 irons over here. So let's put a 3 in front of our iron 2 hydroxide. So now we can also write that there's 3 irons. Right? You can see maybe you can already see what we're going to have to do to aluminum hydroxide over here. We know that we need 2, right? Because there's a 2 up here. So now we have 2 aluminums. There's only 1 aluminum over here. So we're going to need to put a 2 there. That's going to give us 2 aluminums. Now let's count up the oxygens. 2 times 3, because every aluminum hydroxide comes with 3 oxygens, but now we have 2 of them. So we've got 6 oxygens and 6 hydrogens. And if we come back to our other side here, we've got 3 of these molecules, and every molecule comes with 2 hydroxides. So that's going to give us, again, 6 oxygens and 6 hydrogens. So this molecule is balanced when we put a 2 in front of the aluminum hydroxide, a 3 in front of the the iron 2 chloride. It's easy to get tongue-tied when you're trying to say all this stuff. A 2 in front of the aluminum chloride, and finally a 3 in front of the iron 2 hydroxide. Let's do one more. Let's do HClO4 plus lithium 2 carbonate. This is going to give us H2CO3, and this will be a solid, and LiClO4. Alright, so right off the bat, we can look and see if there's anything that we're going to need more of. And I'm looking at lithium chloride over here. There's only 1 lithium on this side, but on this side we've got 2. So let's just start by putting a 2 in front of there. We can keep a tally. Let's tally. We've got 2 lithiums here, and now over here we've got 2 lithiums. What else do we have? We've got a carbonate, CO3. So we've got 1 CO3. How about here on this side? We've got H2CO3. So yeah, we've got a carbonate, 1 CO3. I noticed that with that carbonate I've got 2 hydrogens. We've got 2 hydrogens over here. And we've only got 1 hydrogen on this side. So let's put in a 2. So that gives us 2 hydrogens. And what does that do for the chlorines? It gives us 2 chlorines and 8 oxygens. So let's go over here. And it looks like we'll have 2 chlorines and 8 oxygens. Sometimes you don't get it on the first try. Here we got that. We get a 2, a 1, right? If we don't put anything, that just implies a 1. Same here. and a 2. So that's balanced.